Let's go ahead and do even more clarification and practice around solving with elimination, but also reflecting back on our work with solving by substitution and elimination. And so we have 5 systems here, and we're going to start off with the one where it says system number 1, the system is ready for the substitution method. So let's think about why that is the case. Notice on our 2 equations, we have one that is solved for x. And when we have one of the equations solved for a variable, or if we get something that is easily changed and solved for a variable, then we can use what's on the other side of that equation and use that for our substitution. So in this case, the second equation is solved for x, and so we have that 5 minus y that is equal to the x. It's kind of like the x is kind of like a $20 bill, and the 5 minus y is like 4 $5 bills. They're equivalent to each other, so we can trade one out for the other. So in this case, we're going to trade out the 5 minus y and the x for the 5 minus y. So we can do the substitution step on this one. So let's go ahead and write that over on the right side here. So that would make our new equation rewritten 2 times 5 minus y plus 3y is equal to 12. So again, if we think about what we're substituting in here, so we got the x is equal to 5 minus y, and we're putting that in for x in our first equation and then rewriting that equation. Okay, so now we've done a number of these problems that essentially comes down to solving. Can we solve for y? Can we go through our solving steps here? So let's go ahead and do that. You should see some similarity to what we have done on a number of these problems. And so usually at this point, we have a little distributive property that we need to do. So I'm even going to write that over on the side here, like I've done before. So distributive property. And so 2 times our 5, 2 times 5 is 10. 2 times a minus y, remember that's like a minus 1y here, a minus 1y. So 2 times negative 1 is a minus 2y. And then plus 3y is equal to 12. And after we do the distributive property, so I'm going to get that lined up a little bit more here. So distributive property. After we do the distributive property, then we usually have some like terms that we are going to combine together. So in this case, we've got the minus 2y and the 3y on the same side of the equation. So we can combine like terms. And so that is going to give us our 10 still. And then negative 2y plus 3y would be a positive 1y, or just plus y, plus 1y is equal to 12. All right, and then we go through just our 2-step solving steps, although in this case it's really just one more step that we have to do. So to isolate the y, we're going to undo the 10 by subtracting it from both sides. 10 minus 10 is 0, so that cancels it out over here, and we're left with y is equal to 2. So that is half of our solution. And remember, we're looking for the intersection of these 2 lines, so we have to go back over to the other equations and look at which one do you think would be easier then to get the x value. You can plug that y equals 2 into either equation, but the one that's probably best to plug it back into, in this case, is the x equals 5 minus y, because that's already got x solved for itself. Right, so we already have y is equal to 2. Right, so we can substitute that 2 in for the y, and therefore get 5 minus 2. And 5 minus 2, of course, is 3. So x is equal to 3. So our solution then turns out to be x value of 3 and a y value of 2, so the coordinates 3, 2. The intersection of these 2 lines would be 3, 2. If we put 3 and 2 in for x and y, it would make both of the original equations true. And you can definitely check your answer on Desmos by graphing these 2 equations and double checking that they do in fact intersect at the point 3, 2. No need to bring in a screenshot or anything of the graph here, but I would like you to check your answers by graphing every time you do this. All right, so system number 2, this system is ready for elimination, the elimination method. So let's just again think about what makes it ready for elimination. Notice that neither equation is solved for x or y, so that would tip you off for the substitution method. But with the elimination method, usually one of the sets of the coefficients is the same. So looking at the x's or the y's, has the same coefficient. Sometimes one is a negative and one is a positive. Sometimes they're both the same positive or negative, the same sign. In this case, we have a negative 5y and a positive 5y. So that's going to tip us off to elimination. And when you have the opposites, let's think about what would get those to cancel out to 0. What would eliminate the y values? Adding negative 5 plus 5 would cancel out to 0, would add up to 0. If you did a subtraction here, negative 5y minus 5y, that would give you a negative 10y, which would not eliminate the y. So adding these equations together is going to eliminate the y. And when you add or subtract, sometimes it might be good just to write that symbol all the way across here to remind you what you're doing. So we're going to add these equations together to get a new equation. So 3x plus 6x is going to give us 9x. Negative 5y plus 5y is 0. Negative 19 plus 37 is 18. So simplifying that means we have 9x equal to 18, and 9 times what is 18? 9 times 2 is 18. If we divide both sides by 9, we get x is equal to 2, and that is half of our solution. Let's get the other half. Again, we'll look back up top here and see, okay, we've got to plug that into one of the equations. Which one would be easier to plug it back into? I don't know that it's incredibly obvious here, and it could work either way, but I do like when I have a bunch of positive values, even when they're a little bit bigger. So I'm going to plug it into the 6x plus 5y equals 37 equation, and we're going to have to do a little work here to solve for the y. So if the x is 2, we're going to plug that in for x. So 6 times 2 plus 5y is equal to 37. Let's just simplify a little bit. 6 times 2 is 12. So 12 plus 5y is equal to 37. Now let's go through our solving steps. So to undo from both sides, let's go ahead and subtract 12 to undo the adding or subtracting, to undo that number that's hanging on the end, work our way back towards the y and get the equation solved for y. So then we have our 5y is equal to 25. 37 minus 12 is 25. And then dividing both sides by 5 to undo the 5 times y, we will divide. And if we divide both sides by 5, that gives us y is equal to 5. So our solution turns out to be an x value of 2 and a y value of 5. And once again, if we are checking our answer on Desmos, we would plug in these two equations up here. We would graph them and look for that intersection point and confirm that the coordinates of the intersection are in fact 2, 5. X value of 2, y value of 5.